Hi everyone. This is my final project for IST 652. My projects will be focusing on Boston crime data analysis. Let's start it. This is the outline of my final presentation. I will start from introduction to introducing what I want to achieve in the final project, the dataset itself, with some description, the data cleaning procedure that I use, data visualization for better understanding of the datasets. I also use the descriptive analytics to answer question 1 and 2. Those two questions will be talked about in the later slides. And also I will use machine learning procedure or techniques to uh, evaluate or predict the shooting case. I will also talk about the model performance of my machine learning algorithm, and the last page will be reference. So start from the introduction part. Crime rate has been increasing in the past few years in Boston. According to U.S. News, Boston, as a major city in Massachusetts, need to address the issue with crime that happen in different districts in order to keep the safety of this community. However, there are lots of challenges to overcome. For example, there are new types and formats of crime, such as cybercrime. For this project, I want to help Boston Police Department by analyzing the Boston crime datasets. I'm planning to use data mining and machine learning that I learned from this course to help police department to better allocate its force to when and where it should be. So this is the dataset itself. On the left side, you can see the information about the column, the shape of the dataset. You can see it has a lot. It's a really large dataset with more than 31,000 entries and 17 columns. The dataset itself is connected by Boston Police Department in order to record the detail of each encounter incidents, and it's collected between 2015 and 2018. The dataset contains a large amount of variables and 17 columns, which records information like data of the incidents, whether the incidents involved to shooting or not, the location and the time. Also, before I start the analysis, I did some data cleaning procedure. I replaced NA in shooting variable with N. I convert day of week to an order category. I replace the missing value in latitude and longitude variable with a -1. I remove the unused column. I have also converted occurred on date variable to data time. Um, I also remove all duplicate records, and last step I use is drop all rows with missing value in because the dataset is quite large and I'm only drop a really small portion of the dataset itself. This is the first data visualization that I did. This is the crime frequency based on the offense code. Offense code is basically the title of the crime. You can see the number one, um, incidents recording here is motor vehicle accident response from the police department, and also you can see it has almost more than 30,000 cases. This is also another data visualization that I did for the Boston Police Department. This is basically showing the area where it has the most of the crime. You can see in downtown Boston, where the color is almost orange in here, which shows most of the crime are happening in the downtown of Boston. So start from some question that I want to address for the police department. Like how does crime change in Boston over time? Is crime increase or decreasing over the year, months, hours? Which area has more crime than other area? What are some of the most frequent crime in the Boston? What is the crime trend across the district? So you can see this is basically three graphs by year, months, and hours. You can see 2016 and 2017 has most of the crime from the datasets, and months July and August has most of the crime. And in a daily base, in the afternoon time between 5 p.m. and 6 p.m., where it has a lot, most of the crime happened. Um, this is another plot for street that has most of the crime with the street address located on the right hand side with the count of the number of uh, incidents that happened. You can see Washington Street has most of the record count with 14,109 cases. Washington Street, if you search Google, you will also find out it is street that located in downtown Boston. So what I will suggest for the police department is to spend more resources or patrol force to patrol the Washington Street more frequently than other street. This is the most frequent crime that record in the dataset. Like I mentioned before, the motor vehicle accident response has most of the count. It has more than 30,000 in this case. Uh, this is a crime trend in different districts across the different year. The four line shows for different years, and on the x-axis is the number representation for different districts in Boston. One thing to notice here is the B2 area. B2 district that has most of crime across all the different years, and also 2016 and 2017 are really identical, and they have most of the crime compared to 2015 and 2018. So the next question that I want to focus is the crime that involve with gun violence. Gun violence is the leading cause of premature death in the U.S. and it kills more than 38,000 people and causes nearly 85 injuries each year, according to American Public Health Association. In the following slides, I will be focused on analyze the gun-related crime in Boston. So start from the question, how is gun violence trend in Boston change over time? Is gun violence crime increasing or decreasing over the year? What is the shooting trend over the months? What is the shooting trend across the different district? Which crime are more involved to gun violence? So start from the first question. We can see 2017 has most of the gun-related cases, and a little different compared with the previous plots. You can see June and July has most of the gun-related cases. And one thing to notice here is by day, you can see Saturday and Sunday has most of the gun-related crime. That I think that tells us that gun-related crime are more likely to happen in the weekend. So police department may want to consider that. This is a plot for shooting across district. Like I mentioned before, you can see the B2 area is quite dangerous, and it has most of the gun-related crime with about 300 cases recorded. Also, for the street that has most of the crime, we can see here aggregate assaults actually has the offense code group actually has most of the crime with the aggregate assaults. And on the right hand side, you can see it has more than 500 cases recorded. For the machine learning algorithm, I did a logistic regression for supervised algorithm, and I also did a k-means cluster analysis for unsupervised. So logistic model used to predict the probability of the shooting using offense code group variable. The reason why I choose shooting as my y variable and only keep offense code group as the x variable is those two variables are highly correlated. You will see this in later performance of this model, which shows the offensive code group predicts whether the crime involved into shooting or not really accurate. In these cases, because logistics regression only works with binary outcome, I have changed the shoot y and n in shooting variable to 1 and 0 correspondingly. So this is the confusion matrix after I run the logistical regression. You can see here I achieved a really high accuracy with almost 99, almost 100%, correctly predict whether the crime involved in gun shooting or not, and also calculate precision recall and F1 score. Basically, because the accuracy is so high in here. So the results that I think about is from the logistical regression is that we have obtained a really high accuracy, which means the offensive code group are really accurate to predict whether the crime involved in shooting or not. The high accuracy tells us that for 59,314 records used in the model correctly predicts whether the shooting is involved in the crime with the accuracy of 99%, which is really high. So 59,314 records is the size of the trained datasets. That's how I apply the logical regression and basically train the dataset and apply it on the test datasets in order to see the performance of the logistical regression. So in the last, I did a k-means cluster analysis. K-means cluster analysis is an unsupervised machine learning algorithm that used to find the groups of observations that share similarity character. Each cluster means a group of observations. On the left hand side, you can see I start with setting up k equal to 2. K in here, it means the number of cluster. So I will cluster all my records into 2 separate parts, and you can see it represents using different color, yellow and purple here. Later, I changed the number of cluster to 4 to see more how k-means cluster can cluster the number of records in the dataset. You can see this time it separates the crime record embossed into 4 parts, and which showing in yellow, purple, blue, and green colors. And yeah, the last page is my reference for the presentation. Thanks so much for listening. Thank you.